Lesson 6.6 is on surface areas of composite solids. So in this lesson, we're basically using our skills from our previous lessons in this chapter and apply it to find out any figures that would have more than one solid. So for example, if you have a shape like this, it kind of looks like a crayon. You can cut it in the parts where you have the end of the wrapper. So it's going to be a cylinder and a cone put together, and you can find the surface area. Now, one thing that you'll have to be careful for this lesson is that sometimes you're going to have, and oftentimes you're going to have parts that are going to be overlapping. Based on our equations, we have all sides, all the outsides covered. And if you have those overlapping parts, for example, this circle that both cylinder and a cone will have, you cannot count that because that's not on the outside. So you're going to skip it. So either you don't count the circle from the cone or from the cylinder, or sometimes you just don't count either of those sides and then just count whatever that's on the bottom in this case for this composite solid. So you only need the side for the cone, and then you'll need the side for the cylinder, and you just need one circle for this composite solid. The first part, you have to identify the solids when you have composite figure so that you can find out which of these equations you can apply to find out the surface area. So when we have a shape like this, you're going to identify each part. So for example, on the side, you have a rectangular prism. You're also going to have a cylinder, and you're going to have approximately a rectangular prism on the bottom that's attached with a different figure. Or sometimes it could be like this stair or steps to a house. You're going to have two different kinds, or maybe three different kinds of rectangular prism put together to make this shape. The reason why we need to be able to identify them is because depending on what kind of solid we have, the equation that we're using are going to be different, and the sides measurement that we need to know are going to be also different. I think it will make more sense when we work on some example questions. So let's go ahead and work on some example questions. I'm going to give you some examples using shapes from the textbook. I'm going to use page 285 on your own, question number 2 and 3. Number 2, you have a shape that has a cylinder and a cone put together, and it makes almost like a fat crayon shape. So what you're going to do is, as I mentioned briefly in the very beginning, you're not going to count the part that overlaps for the cone and the cylinder. So you're going to first work on the cylinder and then work on the cone, or vice versa. I'm just going to work on the cone first and then move to cylinder, so top to bottom. For my equation for a cone, I am going to skip the very first part because that's going to give me the area of a circle. Because I have the bottom side overlapping, I'm only going to use the side which is going to be pi times r times L. And then I am going to plug in my numbers, which are going to be pi times 3 times 5. Now, just like I worked on the cones in our previous lesson, I am not going to put the pi and the numbers and multiply it right now because I probably will have to add different pi numbers for my cylinder. So I'm going to set that aside. And then for my second part, it's going to be the area of a circle, one of the circles, just one, and then the sides. So I'm going to do pi times r squared, which is 3. So pi times 3 squared plus 2 times pi times r, which is 3, times the height, which is going to be 5. So when I do that, I am going to also put the numbers together and still leave the pi as is. So for the cylinder, it's going to be 9 pi plus 30 pi. So when you add all of them, it's going to be 54 pi. So I'm going to do 54 times 3.14, and that's going to give me 169.56 yards squared. So that's going to be my final answer. Make sure you're putting the squared after your unit. If you put it before, it's going to actually tell me that you're going to do 169.56 times 169.56, and we don't want that huge number. For the second question, which is number 3, you're going to have a composite figure of triangular prism and a rectangular, actually this is a square prism because you have 3 times 3 on the front and the back. Okay, so we're going to take a look at this, and first I'm going to find out the surface area of the triangular prism. So for the triangular prism, I'm going to work with the triangles first. Please make sure you're always dividing the triangles by 2 so that you don't double the area of that. So I'm going to do 3 times 4. They always have to meet up in 90 degrees angle. So I do 3 times 4 divided by 2, and it's going to be times 2 of the answer that you get. If you can, just think of it as, okay, I'm going to multiply it once and for all, and I'm going to cover both triangles. That's fine. So it's going to be 12. So I set that aside. And usually I'll have 3 sides, but because I have the bottom side overlapping with the rectangular prism or square prism, depending on which side you're looking at, so I'm not going to worry about that. I have to just find the area of the slanted side and the right side. So I'm going to work with the slanted sides first. It's going to be 5 times 5. Okay, I'm using this side and this side. So it's going to be 25. I set that aside. And then I also have the right side, which is going to be 4 times 5, and that's 20. And I'm going to set that aside as well. Okay, and I'm going to work on the bottom, which is going to be a square prism. And I know I have 2 sides that are equal for all of them, except I'm not going to count the top part that overlaps with the triangular prism. So the bottom one is going to be just 1, other ones are going to be 2 each. So I'm going to just start with the bottom just so that I can get rid of it. So I have 3 times 5, which is 15. And then I have 3 times 3, and I have 2 of those, front and back. So that's going to be 9 and then 18 for 2 of them. And then I have 3 times 5 on each side. So I'm going to have 15 times 2, that's 30. So now I covered all the sides, and all I have to do is to add all these numbers. And when you add all these numbers, you're going to have 120 centimeters squared as your final answer. A lot of these composite figures are going to have complicated shapes, but once you break down those shapes into 2 or 3 different solids, it's not going to be as complicated. I do want to review finding out an area of this shape. When you have a trapezoid, and this is going to be related to question number 9 from your homework, when you have a trapezoid, which means you're going to have two lines that are going to be parallel. So you have a pair of parallel line, and then the other ones are not going to be parallel. You're going to use a different equation than using base times height. So what you do is you're going to add the top and the bottom length, and then you're going to multiply by the height, which meets at a 90 degrees, and then you're going to divide it by 2, because when you add those, you're going to actually put 2 of those same figure together and extend it and make a parallelogram. And parallelogram is the same thing for finding the basin height and multiplying them for the area. So you find a long area of this parallelogram, and then because you only need half of it, you divide it by 2. So just use this equation and have it in your notes. Base 1 plus base 2 times height divided by 2. So that's going to be your equation. So if you have a shape like this, where you have 3 centimeters for the top, 5 centimeters for the bottom, and height as 4 centimeter, you're going to do 3 plus 5 times 4 divided by 2. So when you do 3 plus 5, it's going to be 8. 8 times 4 is going to be 32, and 32 divided by 2 is going to be 16. So the area of this trapezoid is going to be 16 centimeters squared. So for your homework, you're going to have 6 questions only from textbook page 286, number 6 through 11. We will go over some of these questions because I know you are going to have some questions from these homework set. So try as much as possible to work on the shapes that you can, and then the other ones, I'll go over them together for tomorrow's live lesson.